Hey, I'm going to start using the first derivative test to actually find local extreme values. So let's use the first derivative test to find local extreme values of f of x, which equals 12x to the fifth plus 15x to the fourth minus 40x cubed. So what do I need to do? First, when I'm using the first derivative test, I need to find critical values. And after I find critical values, I need to determine the signs of the first derivative. And the first derivative may or may not change sign at each of the critical values, and that will tell me whether or not I have a local maximum or a local minimum. So let's go ahead and do that. So I'm going to rewrite my function. It is f of x equals 12x to the fifth plus 15x to the fourth minus 40x cubed. So to find the critical values, remember these are places where the first derivative is 0 or the first derivative does not exist. So I find the first derivative and I get 60x to the fourth plus 60x cubed minus 120x squared. And I want to know when this equals 0 or when this does not exist. So for my critical values, I note that f prime always exists. Its domain is all real numbers. So I don't have to worry about that piece, but I did need to consider it. And now I want to find all values where the first derivative equals 0. So I want to set 60x to the fourth plus 60x cubed minus 120x squared, set that equal to 0. So when I'm solving this equation, I want to try to factor the left-hand side. And I get 60x squared times x squared plus x minus 2. And I set that equal to 0, which tells me that 60x, I'm going to try to factor this instead of using the quadratic formula, times x plus 2 times x minus 1 equals 0. And now in order for this left-hand side to equal 0, one of the factors has to be 0. So x squared equals 0, which means x equals 0. Or x plus 2 equals 0, which means x equals negative 2. Or x minus 1 equals 0, which means x equals 1. These are my three critical values. If I had values where the derivative did not exist, it would be these three together with the values where the derivative did not exist would be our critical values, but our derivative always exists, so I have three critical values. So I found my critical values. Now what do I do with them? Now I'm going to take them and put them on a number line and try to determine how the first derivative might change sign near those critical values. So what did I have? I had, let's see, negative 2, 0, and 1. Since this is a number line, I want to write them in order. Down at the bottom, these are my x values. And on the top, I want to indicate the sign of the derivative. I know, of course, at negative 2, 0, and 1, the first derivative is 0. And now I need to recognize that in the intervals that these three numbers break the number line into, so there's 4, 1, 2, 3, 4, the sign of the first derivative is all going to be the same. The only way for the first derivative to change sign is if it either goes through 0 or the first derivative doesn't exist, because this is continuous. So in each interval, I'm going to have the exact same sign of the first derivative. So all I need to do is choose one value. Say I'm going to choose x equals -3 for this interval to the left of -2. I'm going to go ahead and input that into the first derivative and check and see what is the sign. So what I probably should do first is go ahead and write down the formula for the first derivative. It's 60x squared times x minus 1 times x plus 2. So at x equals -3, 60x squared is going to be a positive number. X minus 1 is going to be -4. That's going to be a negative number. And x plus 2 is going to be a negative number. -3 plus 2 is negative. So, since I have this factored, I have a positive number times a negative number times a negative number. So the result is going to be a positive number. This only works because I have f prime factored. But the result is positive, so the sign of f prime is positive. Okay, so now I want to check between x equals -2 and x equals 0, so let's just choose x equals 1. Notice I don't actually care what the value of f prime is, I just care if it's positive or negative. So when x equals 1 is input into the first derivative, 60x squared is positive. X minus 1 is 0. Oh, I've made a mistake. 1 is not between -2 and 0. That was a good indicator for me right there. So, what should I do instead? I should go over here and actually pick a number between -2 and 0. That would make a whole lot more sense. Maybe I should try -1. That's a number between -2 and 0. And let's go back to my number line. X equals -1. Now let's try. 60x squared is positive. -1 minus 1 is negative. And x plus 2 is -1 plus 2 is positive. So I have a positive times a negative times a positive, and that is negative. Okay, so between -2 and 0, I get a negative number. Let's keep going. Let's pick a number between 0 and 1. How about x equals 1/2? So if x equals 1/2, 60 times 1/2 squared is positive. 1/2 minus 1 is negative, and 1/2 plus 2 is positive. So I have a positive times a negative times a positive is negative. So that's a negative number. Notice here's a situation where my interval did not alternate sign. It's not necessarily always going to alternate sign. And then we pick a number to the right of 1. Any number to the right of 1. It doesn't matter what it is. We could pick x equals 5. So x equals 5. 60 times 5 squared is positive. 5 minus 1 is positive. And 5 plus 2 is also positive. A positive times a positive times a positive is positive. So now looking at this number line, we see that our critical value of -2, we change from the first derivative being positive to the first derivative being negative. So we would say at -2, there is a local maximum. At the critical value of 0, the first derivative goes from being negative to negative, so nothing happens there. We don't have a local maximum, we don't have a local minimum. And when at the critical value of 1, the first derivative goes from being negative to being positive, goes from decreasing to increasing. So that means that we have a local minimum. So that's what the first derivative test tells us. Let's write out our answer. At x equals -2, f has a local maximum. the maximum value is, that local maximum value is f of negative 2. We could compute that. If x equals 1, f has a local minimum. The local minimum is f of 1. How would we compute these? Well, we would go back to our original function. Here's our f. To find f of negative 2, we would evaluate the function at negative 2. To evaluate f of 1, to find the local minimum at 1, we would evaluate f of 1. For example, f of 1 is 12 plus 15 minus 40, which is 27 minus 40, or negative 13. That's our local minimum value at x equals 1. And here was our example of the first derivative test.